Now we have to derive potential energy of a system of two charges. This is very important for 3 marks question. Almost every year or every alternate year you will get this question. So listen carefully. So first what I do, I will bring one charge from infinity to point A. This charge is a Q1. So to bring this charge Q1 from infinity to here, no need to do any work, because see, when I am bringing a charge from infinity to a point A, here only one field exists. That field is produced by this charge, that's it. There is no other external field exists in this region. That means there is no interaction of fields. So that's why no need to do any work. So work done in bringing a charge Q1 from infinity to point A is 0. That means W1 is equal to 0. Okay, when I want to bring second charge from infinity to point B, here when I am bringing Q2 to point B, Q2 is moving in the field of Q1. So Q1 repels this Q2 because I have taken both positive charges. So Q1 repels Q2. It repels the motion of Q2. That means I have to do work against to the electrostatic repulsion. So that's why to place this charge at B from infinity I have to do work. So that's why work done in bringing a charge Q2 from infinity to point B is W2 is equal to, we know W is equal to QE. So I am bringing charge Q2 from infinity to point B. Here at point B, potential is due to Q1. So that's why I'll say it is potential due to first charge. Okay. Now I have to, that point B is at a distance r from A. So potential at point B due to charge Q1 can be written as 1 by 4 pi epsilon naught. Charge is Q1 and point B is at a distance r. So that's why at point B, potential due to Q1 is 1 by 4 pi epsilon naught Q1 by r. So work done W2 is equal to Q2 into 1 by 4 pi epsilon naught Q1 by r. So we have formed a configuration. Q1 and Q2 are separated by a distance r. So for this configuration, potential energy, that is total work done, is equal to W1 plus W2, and work done W is equal to 0 plus 1 by 4 pi epsilon naught Q1 Q2 by r. Work done to bring these two charges to position A and position B will be stored in the form of potential energy in the system of charges. So that potential energy is 1 by 4 pi epsilon naught Q1 Q2 by r. Okay, potential energy is a scalar quantity. So that means we must take the sign of the charges when we are calculating potential energy. Okay, for example, both positive, potential energy is positive. Both negative, potential energy is positive. If one is positive, another is negative, then potential energy will be negative. Remember, this is important point. Okay, extension of this concept is to better understanding purpose. Just see, I will bring 3 charges from infinity to vertices of an equilateral triangle. For example, I need to bring 3 charges and they should be placed at 3 points, say A, B and C. Okay, first I will bring a charge q1 from infinity to this vertex. Here I have placed a charge q1. Okay, for that work done W1 is equal to 0 because nothing exists here to repel or attract, so work done is 0. So now I will bring another charge q2 from infinity to vertex B. So to place this charge q2 here, I have to do work because this charge influence will lie here. So that work done W2 is equal to, we know that is QV1, Q2V1. So W2 is equal to Q2 into potential due to this charge at this particular point. If the distance is say R, then that is 1 by 4 pi epsilon naught Q1 by R. Then W2 is equal to 1 by 4 pi epsilon naught Q1 Q2 by R. Okay, now I want to bring a third charge Q3 from infinity to this vertex. See here I am writing Q3. See now when I am bringing this charge Q3 here, this charge influence and this charge influence both I have to take. That means work done in bringing a charge Q3 from infinity to this point is Q3 into here potential due to first charge say V1 and potential due to a second charge is V2. Okay, so that is W3 is equal to Q3 into V1. For example, I have told it is equilateral triangle, so distances are equal between any two charges. So potential at this point due to this charge is 1 by 4 pi epsilon naught Q1 by R plus 1 by 4 pi epsilon naught Q2 by R due to second charge. Then work done W3 is equal to 1 by 4 pi epsilon naught Q1 Q3 by R plus 1 by 4 pi epsilon naught Q2 Q3 by R. So total work done in forming this configuration is W is equal to W1 plus W2 plus W3. That is W is equal to W1 is 0. W2 is 1 by 4 pi epsilon naught Q1 Q2 by R. W3 is 1 by 4 pi epsilon naught Q1 Q3 by R plus 1 by 4 pi epsilon naught Q2 Q3 by R. Okay, this total work done only stored in the form of potential energy of the system. So potential energy of three charge system can be written as 1 by 4 pi epsilon naught Q1 Q2 by R plus 1 by 4 pi epsilon naught Q2 Q3 by R plus 1 by 4 pi epsilon naught Q1 Q3 by R. So this is how we have to write. Okay, this is important. That means every time what I have to do to calculate potential energy of a system, you need to consider all charges interaction. See, Q1 is interacting with Q2, that's why Q1 Q2 by R. Q2 is interacting with Q3, so Q2 Q3 by R. Q1 and Q3 are interaction, so Q1 Q3 by R. In case of a 4 charge system, for example, I will take a square of side A. I will place here charge Q1, Q2. For example, I will take one negative minus Q3 and Q4. Now I need to calculate potential energy of this configuration system. See here what I do, potential energy directly. See, first I have to bring Q1 here. That means work done is 0 because there is no external electric field exists here. Only field due to Q1. A charge never experiences force because of its own field. Okay, now I have to bring Q2. To bring Q2 here, I need to do work against Q1 repulsion. So that's why W1 is equal to, W2 is equal to Q2 into V1. Okay, now I have to bring Q3 here. So W3 is equal to Q3 into V1 plus V2. And to bring a charge Q4 here, I have to do work W4 is equal to Q4 into. Actually here potential is due to first charge, second charge as well as third charge. That means V1 plus V2 plus V3. If you sum all the work, you will get this potential energy. that I am writing directly here without doing all this mathematical simplification. How I am doing? See carefully. See, I have to consider all interactions. See, Q1 and Q2 are interacting, so that's why for 1 by 4 pi epsilon naught Q1 Q2 by A, because side of the square I have given A. Okay, next these two are interacting, one is positive, another negative. Q2 into minus Q3 is minus, plus into minus is minus. So 1 by 4 pi epsilon naught Q2 Q3 by A. Next Q3 and Q4 are interacting, one is negative, another is positive, so this is minus 1 by 4 pi epsilon naught Q3 Q4 by A. Next Q4 and Q1 are interacting, so that's why I'll write both positive charges, so positive potential energy, so that is 1 by 4 pi epsilon naught Q4 Q1 by A. We have taken all interactions. See, Q1, Q2 I have taken, Q2, Q3, Q3, Q4 and Q4 and Q1 I have taken, but Q1 and Q3 are also interacting along this line, and Q2 and Q4 are interacting, so that's why we will get two more terms here, so plus. See, one is positive charge, the second one is negative charge, so that's why plus into minus is minus. 1 by 4 pi epsilon naught Q1 Q3 by this distance is A, this distance is A, this distance A, this distance A, this is diagonal, that is root 2A. So that's why here I have to write root 2A. Do it carefully. These two are positive charges, so potential energy is positive. 1 by 4 pi epsilon naught Q2 Q4 divided by root 2A. See, now what we are going to do is, we'll bring two charges in the presence of external electric field. Previously what we have done, we brought two charges in the absence of external electric field. Now we are going to do in the presence of external electric field. See, imagine here electric field is existing. That electric field may be a uniform electric field, may be a non-uniform electric field. I am not bothered about the uniformity or non-uniformity of the electric field. Here electric field exists. To bring a charge Q1 from infinity to this point A, in the external electric field, I have to do work. That work is said W1 is equal to, see, at this particular point, potential I can take it as VA. So work done is Q1 into VA. Okay, now I am doing work to bring a charge Q1 from infinity to this point, because here already electric field exists. At this particular point, potential I have taken VA. Here potential I can calculate simply by the definition. If you bring a unit positive charge from infinity to this point, work done is called potential at that point. That potential I will say it is VA. To bring a Q2 from infinity to here, I have to do two works. One work is to do against the external electric field, and another work is to do against the electric field of Q1. Okay. So to bring a charge from infinity to point B, I have to do two works. That work is W2 is equal to, one is against to the electric field, external electric field. Here I will take potential is VB, that is Q2 into VB. This is the work I have done against to the external electric field. Now I have to do work against to Q1. That can be done by using formula Q2 into V. At this particular point, potential due to Q1 is 1 by 4 pi epsilon naught Q1 divided by distance between A and B is R. So I will write 1 by 4 pi epsilon naught Q1 by R. So total work done W is equal to Q1 into VA plus Q2 into VB plus 1 by 4 pi epsilon naught Q1 Q2 by R. This is the work done in bringing a two charge system in the presence of external electric field. Usually in examination they will ask work done to form a two charge system in the absence of external electric field, they will ask. So learn the first point very carefully.